All right, so let me do a little bit of a lesson here on lenses. These are lenses, not mirrors. So I find that sometimes people get mixed up between the two when we switch over to lenses. They are similar, but they are certainly not the same. All right, so what I've got here is a convex lens. This is convex, and this is also known as a converging lens. It is converging. It is converging because that describes what it does, versus convex refers to the shape. So what we have is some object that I'm going to place at some relatively random location. I'm going to put it here. It is going to be outside of 2f, where f is the focal point and 2f is 2 times farther than the focal point. If you recall, when we had a mirror, let me do that real quickly. If this was a mirror here, a concave mirror, then 2f would be also the center of curvature, c for the center of curvature, and that would be the relation there. But there is a significance to 2f that I'll get to in a little bit. All right, so what we're going to do is we're going to draw ray diagrams for this. So please be sure that you put all the f's and 2f's at their proper location if you need to draw it from scratch. So what I mean by that is that if I were to take, that's not what I meant, if I were to take a ruler and place it here at this midline of the lens, you'll notice that f is at 3 inches and 2f is at 6 inches, and I have the same thing on the other side. They must be completely the same on each side. All right, so now let's go ahead and draw the ray diagrams. All right, I'll just go ahead and do them all in black to make it go a little faster and easier. So I'm going to go parallel, and then I'm going to go through the focal point on the other side, just like that. Another one, I'm going to go from the tip of the object through the center of the lens as if nothing were happening. And notice that each time I am drawing from the tip of the object. So where the base of the object, there will also be the base of the object somewhere out here. In fact, I'll tell you that this is the cross section. So whatever this here represents, then this section here represents the same spot on the object, except now this is the image. And then we're going to have something like this, where we've got drawn my object, so it is inverted, and I've tried to draw it relatively to scale. So this location here relates to this location here. And I can also draw a last ray diagram, or ray I should say. It's going to go through the focal point on the near side, and then once it hits the midline of the lens, it is then going to go parallel, and you notice it hits the exact same spot. So that is the ray diagram for when an object is outside 2f. Let's switch over to when it is at a different location. Let's put that object inside of 2f. I'll just move its label over here. And so let's do the same thing. It's pretty much the same procedures. We're going to go parallel and then through the focal point. We're going to go straight through the center as if nothing were occurring, and notice that these two rays are diverging. I cannot go through the focal point anymore. If the lens were big enough, I could show that it would actually go away from the focal point and then parallel. So if the lens, and I could pretend as if it was extending, I can pretend as if the lens went up all the way up there, it should work out the same way. And if I were to trace backwards, so since that light ray is moving out for all of existence, forever it's going to move away, I can now line of sight. So if I were to have your eyeball here like this, and here you are looking up along the ray as that light beam comes to your eyeball, you're looking backwards. So I can trace backwards like so, if I try and do it as straight as possible. So we're tracing backwards, and these should come to the same spot. I'm not doing it perfect, but it's pretty close. So right about here is going to be the tip of the image, and so my image is going to be something like that. it's going to be large, it's going to be virtual because no light actually gets there, as opposed to the previous one. This was a real image because all light energy does in fact get there. This is virtual. It is upright, large, and virtual. Okay, so let's see if we can go back a bit. Let me undo all this work that I've done. And now I'm going to place this object at 2f, and there's something I want you to notice. And I'll do it relatively quickly now that you're getting the hang of it. I'm going to parallel through the focal point. I'm going to go straight through the center as if nothing had happened. I'm going to go through the focal point and then parallel. And I must have done something not quite right here because it's not matching up exact, but and I can even fix that one a little bit. Makes it a little better. This one actually should go up a little bit more too. There, that's better. And now I can place my object over, or my image rather, over here, and you'll notice that if my object is at 2f, then my image will also be at 2f. So that is the significance of 2f. It just gives you a benchmark to go off of. All right, so those are convex or converging lenses. Now let's look at concave or diverging. So this is concave, or it is also diverging. It is divergent. So if I can put an object anywhere I want, the 2f significance is not quite the same here. All right, so if the object, what I can do is I can go parallel, and then rather than going to the focal point, this is diverging, so it's going to go away from the focal point. Well, with my smartboard here, I can cheat a little bit, so you can see that this is going away from the focal point. I'm going to extend it out like that. And again, line of sight, since I have the tip of the arrow here, line of sight would trace me backwards. I'm going to actually use my smartboard tools to help me out with that one. There we go, like that. And then for the next, I would go again straight through the center as if nothing wrong or as if nothing different were occurring. And let's see here. I can also go to this focal point, but I'm going to stop short of it, and then from there it will go parallel. And if I trace that one backwards as well, looks something like that. In fact, let me go farther back. Let me just say that line of sight goes that way. And you notice that they all converge. In fact, I should use a different color, that way you can see it. They all converge to there. There's no actual light rays converging there, but that is the image location, and I'll put my arrow. Again, the base of the object is here, so the base of the image will be here. And it is upright and virtual and smaller. All right, so hopefully that gets you what you need to do in order to draw the ray diagrams for lenses. Please note that these are different than mirrors. They are going through, not bouncing off. And so you have parallel, then either to or away from the focal point. You've got through the center as if nothing happened. You've got to the focal point, to or away from the focal point, and then parallel. Okay, and that's true of every single lens and mirror. Just with lenses, it goes through and does not bounce off. All right, well, let me know if you have questions, and talk to you later.